Have you ever really thought about what's happening when you use Bitcoin on your phone? I mean, it feels so seamless, but we're talking about a massive global financial network, a digital ledger that's constantly growing. How in the world does all of that fit onto the little device in your pocket?
It really does seem kind of impossible, doesn't it? If you've ever wondered how your mobile wallet can be so quick and easy without downloading the entire blockchain, well, you've hit on one of the most clever and most important design choices in the entire Bitcoin world. All right, let's put this into perspective. To run what's called a full Bitcoin node, you need to download every single transaction ever made. That's over 500 gigabytes of data, and it's growing every single day. Your phone, on the other hand, it runs its wallet using just a few megabytes. The difference in scale is just staggering. So, what's the secret? Well, your phone uses a shortcut, a really, really clever one. But like pretty much any shortcut in life, this convenience doesn't come for free. There's a trade-off, a hidden cost that we're gonna unpack. So first, let's just be clear about the problem your phone is up against. Trying to cram the entire Bitcoin blockchain onto a smartphone, it's literally like trying to fit an ocean into a puddle. It's just not gonna happen. A full node checks everything, all the way back to the beginning. Your phone just doesn't have the space, the battery, or the horsepower for that kind of work. So to get around this, your phone's wallet, which we call a lightweight client, does something smart. It only downloads the block headers. You can think of these as just the chapter titles of the blockchain, not the entire book. And by doing this, it's dealing with a data set that is about 10,000 times smaller. That's not a typo, 10,000 times. And this brings us right to the shortcut itself. The technical name is Simplified Payment Verification, or SPV. But honestly, the best way to think about it is like you're a tourist trying to find your way around a brand new city. A full node is like a tourist who has a perfect, detailed map of every single street, every alley, every landmark. It knows exactly where it is at all times. It's totally self-reliant, you can't trick it. Your phone, the lightweight client, is like a tourist who showed up with no map at all. To get anywhere, it has to stop and ask strangers for directions, and those strangers are the other nodes on the network. So, if our mapless tourist doesn't actually know the layout of the city, how can it ever be sure it's at the right place? How can your phone know a transaction is real if it can't see the whole picture? Well, basically, it does it by trusting the crowd. Here's how it works. First, your phone gets that lightweight chain of block headers, the chapter titles. Then, when you get paid, it asks a full node for something called a Merkle path. This is what cryptographically connects your specific transaction to one of those chapter titles. Then, it just waits. It watches as new blocks get added on top. After about 6 new blocks, your wallet goes, okay, looks legit, trusting that the rest of the network agrees. So this Merkle path thing sounds complicated, but you can just think of it as a cryptographic receipt. It's a tiny piece of data that proves your transaction is definitely included inside a specific block, without your phone having to see all the millions of other transactions in that block. It's an unbelievably efficient trick. And right here, this is the most important takeaway. Your phone is fantastic at proving a transaction exists. But because it doesn't have the full map, it has no way of proving that a conflicting transaction, like someone trying to spend the same money twice, doesn't exist. It can see what's there, but it's totally blind to what isn't. And that blindness leads us straight to the hidden costs we talked about. By constantly asking other nodes for directions, hey, can you tell me about this transaction? What about this one? Your wallet is basically shouting your business out to the network. And that creates some serious privacy issues. Think about it. If a bad actor is listening, they can start to connect the dots and figure out which addresses belong to you. They could even lie to your wallet, maybe hide a transaction from you, or even connect you to a whole fake network of nodes that they control. Your wallet is always operating on the hope that it's talking to at least one honest stranger. So, how do you fix this privacy leak? You can't just have your wallet broadcasting everything. Well, this is where another really clever idea comes into play. It's called a Bloom filter. It's a way for your phone to ask for directions without revealing its final destination. You see, if your phone asks a node, hey, do you have any transactions for this one specific address? That's a dead giveaway. It's like our tourist standing on a corner and yelling, hey everyone, I'm going to 23 Church Street. A Bloom filter lets the wallet ask a much vaguer, much fuzzier question. Instead of asking for one address, it asks for any transaction that matches a general pattern. This is like our tourist asking a local, excuse me, are there any streets around here whose name happens to end in UNCHH? And this is where it gets interesting, because the user gets to make a choice. You can tune this filter. If you make the filter very specific, you'll get accurate results, but your privacy is low. If you make it very vague and fuzzy, you get great privacy, but your phone has to download and sort through a bunch of extra irrelevant transactions. Which brings us right back to where we started. It all comes down to this fundamental balance. When you use a Bitcoin wallet on your phone, you are actively making a choice between absolute mathematical certainty and simple, everyday convenience. The upside of a lightweight wallet is amazing. It's fast, it's efficient, it fits in your pocket. The downside is that its security is based on trust and probability, not absolute proof. Now, for most of what we do every day, that model is perfectly fine. It's secure enough. But if you demand infallible, cannot be fooled security, well, that only comes from running a full node, from carrying the entire map yourself.
And that really leaves us with a much bigger question, one that goes way beyond Bitcoin. We make these kinds of trade-offs every single day with our technology, from social media to cloud storage. So it's a good question to ask yourself, in your own digital life, how much certainty are you willing to give up for a little more convenience?